In this video, we will be talking about how to solve a system of three equations with three variables using the Gauss-Jordan matrix reduction method. Here is the problem that we've looked at in one of the earlier videos. 2x plus 3y plus z equals 4, x minus 5y plus 2z equals 13, and 4x plus y minus 3z equals negative 2. The first thing that we need to do is to write this system of equations as a matrix. Each of our coefficients for each variable will have its own column, and each equation is translated into a row. We can see what the finished matrix looks like here. Our goal is to take this matrix form of the equation and turn it into reduced row echelon form, or RREF form. That looks like this here. Notice that we have ones down our primary diagonal here, and all other numbers in each column where there's a 1 are zeros. Staying organized when solving a matrix problem is very, very important. Here are a few clues that will help you to stay organized and continue to do legal row operations, which will progress you towards your goals. First, only deal with one column at a time. Work from left to right. That is, first take care of the x column, then take care of the y column, and finally take care of the z column. Make sure that your pivots, those are those leading ones that we saw the diagonal, make sure that those pivots are non-zero and that all other numbers in the column are also 0 before you move on to the next column. So, here's our starting matrix. The first thing that we want to do is to work on the x column right here. The first thing that we want to do is to identify the pivots. Those are those, again, in that RREF form, those were those leading ones that we saw that went down that primary diagonal. The pivot spot in the x column is always going to be in row 1. That's the number in the top left corner of the matrix here. Now, notice that when we looked at our REF form, those leading ones were always 1s, and those pivot spots need to become a 1 eventually for us to get into that form that we desire. There's a couple of great questions to ask yourself when you go to see if you can turn a pivot into a 1. There's a couple of easy ways to do it. First, can you switch a row with a row below it to get a 1 in the pivot spot? Or can you divide the entire row by a number to reduce the row without getting any fractions or decimals? If you can do one of these, then yes, absolutely, it will make your life easier and you should try to get a 1 in that pivot spot. If not, don't bother. It'll lead you to using fractions and decimals and will make a very messy solution. We'll just wait and make it a 1 at the end of the problem. So let's go back and look at the matrix that we have right now. Here is our pivot spot. It has a 2. Is there an easy way to make it a 1? Absolutely. We can switch rows. There's a 1 in the same column already right below it. If we switch row 1 and row 2, we'll have a 1 in the pivot spot, which is going to be nice. So we're just taking everything in the first row, switching it with everything in the second row, and we get this matrix right here. Again, notice the second row was 1, negative 5, 2, 13. That's now 1, negative 5, 2, 13 up here on the first row. The first row is now our second row, 2, 3, 1, 4, 2, 3, 1, 4, and our bottom row remains unchanged. Switching rows is one of the legal operations that we can do to simplify a matrix. Okay, so now we have a 1 in the pivot spot, which is great. The next thing that we need to do, again, remember we're still working on the x column. The next thing that we need to do is to get the other numbers in the x column to be zeros instead. Here's our pivot row for the x column. Again, we're working on the very first row, and so that's our pivot row. We want to get those other values, the 2 and the 4, to be 0. How do we get zeros in the x column? Well, any time that you want to get a 0 somewhere, we need to use the third legal row operation that we talked about before. This is what it said. Add a non-zero multiple of one row to a non-zero multiple of another row and replace either row with the result. This sounded kind of confusing, so let's take a look at what that's going to mean for us. When you're trying to get a zero, you always want to use the row you're replacing and the pivot row. Multiply each row by something that's going to get the numbers to be the same. Add if the signs are different, or subtract if the signs are the same, because remember, we're trying to get zero here. All right, so let's see this in action here. We want to try to get a zero in that row, in row 2 in the X column. So we're trying to get this to be a zero right here. This is our pivot for the X column. Never change the pivot row. So we're going to leave this row 1 alone. Row 2 is the row that we want to change. So anytime that we want to change a row, the first thing that we do is write down the row we want to change, which is row 2, and the pivot row, which is row 1. Now we want to get something that we can get both of these rows to multiply. Only concentrate right here on the X numbers. This is how we're going to get our rule. Right now we have a 1 and a 2. We can get both of those numbers to be a 2. If we multiply the first row by 2 and leave the second row alone, that will get both of these to be 2. Now, the signs are the same, so if we're trying to get 0, this is going to be a 2, this is going to be a 2. We want to subtract. All right. Now remember, these were called elementary row operations. What that means is that it's something that we have to do to change and replace the entire second row. So we start out with what we wanted to start with here in the X column. The value for row 2, which is 2, minus 2 times the value of row 1, which is 1. 2 minus 2 times 1 is 2 minus 2, which gives us 0. Now we have to do this same thing all the way across the row. Remember, we're replacing the entire second row. So we go on to the Y column here. Again, we follow the rule again. The value for row 2, which in this case is the 3, and then subtract 2 times the value for row 1. In the Y column, that's a negative 5. So 3 minus 2 times negative 5. Work on your math carefully there. Be really careful when you're multiplying with negatives. We have 3 plus 10 is equal to 13. That minus and the negative end up making that a plus. Now go on to the Z column. Again, keep following that rule. The number in row 2, which is a 1, minus 2 times the number in row 1, which was a 2. And we do that, and we get 1 minus 4, which is a negative 3. Last, we're to the number column. Same idea again. The number in the second row is 4 minus 2 times the number in the first row, which was 13. And we get 4 minus 26 equals negative 22. Okay, so here the first row is the pivot row. We're leaving that the same. The second row is what we were trying to replace here by using this new operation. So all of this math that we did is giving us the new values for our second row: 0, 13, negative 3, negative 22. We can fill those in on our matrix. So by doing this so far, what we've done is we've given ourselves, we now have a 1 in the pivot spot and we have a 0 in the second row. This is awesome. We're well on our way and into getting our matrix to look like it's in reduced row echelon.